What's up, guys? This is Open Source Fiend, and today I'm going to show you how to do high resolution screen captures in Linux. I'll start by saying that right now I use OBS, and I recommended that in one of my other videos. But the more screen captures I do, the more videos I record with OBS, the less I like it. I mean, it's great. It's a great tool to get started with. Maybe it works better on Windows, and it's certainly user-friendly. And it's on Linux, which props to them. However, if you've watched any of my other videos, you'll probably see that literally every single one of them contains, I don't want to call them screen tears, but I don't know what to call them. There are glitches or seizure-inducing flashes of my current background. And I don't want to post videos that have that in them anymore. So I went ahead and I taught myself how to do the screen captures using maybe not a better tool, but something that I feel I have more control over. Also, if you play a game that's got a high frame rate, and like I said, maybe it's different on Windows, but on Linux, the video quality goes to shit. I haven't posted any, but I've recorded myself just playing Doom, like not anything too graphics intensive, and even that gets pixelated and frames get dropped. So anyway, let's get started. So the first thing you're going to need to do is compile Ffmpeg yourself. And luckily, Ffmpeg is well documented, and they actually have awesome compiling instructions. So to get it out of the way, if you wanted to, you could do it this way. And I mean, I have it on here, but it wasn't compiled with some of the things that we're going to need. So for instance, in here, let's see if I can grep this. Pulse. I guess I'm not grepping standard out. Anyway, the flags in here do not contain pulse, and they do not. This doesn't have what we need to do hardware acceleration. So without those two things, I wasn't able to get audio in a way that I liked without having pulse, and the frame rate drops and the artifacts, the pixelation, without hardware acceleration, I don't know if you can get around those. I don't know how extensively I tested it, but hardware acceleration is preferable anyway, especially for CPU usage. So with that in mind, actually, let's keep a monitor open. So, all right, first thing we got to do is get Ffmpeg. So let's take a look here, and that was important. I've seen it, and so I just escaped it, but take a look at that when you go to Ffmpeg. So let's see where to get the source. Was it right there? Download snapshot. I don't want the snapshot. Where is the source? Let's do compile ffmpeg Ubuntu. So I'm on Linux Mint, but it's the same with Ubuntu, or it's compatible with Ubuntu stuff. It's based off of Ubuntu. Yeah, we're not going to do that. We want to install it ourselves. So, all right, this says the first thing we need to do is get the dependencies. So I've already installed these, but I'll go ahead and do it anyway. It doesn't like that. I don't like that. So let's get this out here. Now, you're not required to do this, but I prefer my terminal commands to all be on one line. Like I said, you don't have to, but do that. There we go. So we'll install that stuff. Like I said, I've already done it, so it won't. Whoa. Are you root? Permission denied. Shit. That's great. I don't think I'm installing anything else anywhere. I'll close all my other terminals. Let's make sure I don't have another one open. Nope, that's the only one. One more time. Damn it. Oh, what the hell? And I don't like that quiet shit. I want to see that. Wow. Well, you're going to have to do that. So let me show you what I did. I just got finished saying that it was well documented. So when you take this command, sudo apt-get update, that's fine. You can get rid of the QQ if you want. I don't like things to be quiet. So the problem here is that apt-get update was run with sudo, but then the other one wasn't. I don't know why they would do that. So just stick a sudo in front of the other apt-get, or yeah, the other apt-get. Or if you'd rather, you can just update it yourself. Do the sudo apt-get update yourself, and then run this command as sudo. All right. So now that that's done, let's go back here. All right. So we installed the dependencies. And in your home directory, make a new directory. All right, so I've already done this, so I'm going to go ahead and delete what I've got. Let's rm sources. Let's get rid of that. Oops. And then let's get rid of the bin folder. Let's make sure I don't have anything in the bin folder other than ffmpeg. Okay, yeah, it's fine to get rid of those. Those all come from ffmpeg. So, bin. Okay. So, let's come back here. Make the dir. So I'm going to do that. Cool. Compilation and installation. So, I don't know what NASM is. I don't remember if I installed it. I don't think I did. Same with this one. It just says an assembler used by some libraries. Not too worried about that. H.264. That is something that I want. And the reason for that is that that is it's a relatively, it's not the most modern, but it's a modern video encoder, and it's supposed to be pretty good. And I think that in order to do hardware acceleration, that is the encoder that you have to have. Otherwise, you can compile it yourself. All right, I'm not going to do that because this should have worked. Not going to worry about X265. Not going to worry about AAC. I do want MP3. We might not use it, but we might. So I'll do that one. Lib opus. I don't care about opus. I don't care about VP8 or VP9. And then finally, ffmpeg. So let's do this. I'm going to take all these commands, and we'll put them into a text file. If you want to exactly copy what I'm doing, I'm using Sublime Text, but you can use any text editor you like. So let's just step through these one by one. So we'll go into that directory, and this is the actual ffmpeg source code. Get that? Cool. This is the tar command that's going to extract the source code. There it is. And apparently that tar command makes an ffmpeg folder, so we'll go into that. Make sure we're looking good. Okay. All right. This, excuse me. This is the command that we need to pay attention to. We don't have to pay attention to it too hard. A lot of the defaults here are fine. You don't have to make it all one line, and in fact, for readability, you shouldn't. So I'll wait for that actually, or maybe I just won't do it all in one line. All right, so what is this going to do? So for starters, this is going to add that user bin file, or the user bin folder that we created. It's going to add it to your path. What is the path? The path is how Linux knows where to find particular executables. So anytime you run a command in the terminal, it either needs to be in the directory that you're currently in, or it needs to be accessible on your path. So let's take a look at what path actually is. I think I can do it like that. Yeah. So this is a bunch of folders. They're separated by these colons right here. So on your Linux machine, every single one of these folders contains any number of executable files that Linux can run for you from any directory. So normally, if you were going to run an executable in a directory, let's say I wanted to run, well, I already know that ffmpeg is installed, even though it's the wrong one. Oh. That might be because it's in this directory. Let's go up one. Or let's just go back to the home folder. Ugh, no such file or directory. All right, well, that was a bad example. Nemo is the file manager in Linux Mint. So if I open up a folder, here, this is Nemo. So if I run that, boom, there it is. Now, obviously, there's no Nemo in this directory. N. There's no Nemo. So how does Linux know where to find Nemo? You can determine that by running which Nemo. So it thinks that it's there. And if we were to ll user bin, we should be able to find Nemo. There it is. So how did Linux know to look there? I mean, that's just some random directory, right? The answer is because that particular directory exists on your path. So that was /user/bin. I bet we could find it. And here it is, user bin. So if it's on your path, Linux is going to look there for executable files. So what we need, so anyway, what this is going to do is set your path variable to include your home directory along with bin. Now, I've already done that because I ran this before, but it's going to create this entry right here. Package config path, that's just an environment variable that the configure script needs, I think. Prefix, that's probably, so all right, when we get down to these are all configuration flags or compile flags. So if I thought I installed ffmpeg. It knows to look there. Let's maybe something happened and I need to reload a terminal. Let's find out. There it is. So I knew it was there. So it's telling me that these were all the flags that it was built with. That's all these indicate. So these are just compilation flags to tell ffmpeg how you want it to be configured when you build it. So I'm gonna skip these and this because they don't really matter for what we're doing here. All right, so this is where we get into the stuff that you would be interested in and that I am interested in when it comes to the options I'm going to have with ffmpeg after I compile it. Don't know what that is. Libass. I don't know what that is. All right, so it already has MP3 lame. It already has our MP3 encoder selected to be built. Opus, Theora, Vorbis, VPX. Don't really care about those. All right, care about this one. And the reason I'm not deleting these, even if I don't care about them, is just because they're the defaults. And unless I really know what I'm doing, I don't like messing with the defaults. And I don't know enough about this to determine what I do and don't need, at least in terms of what they're suggesting. So the reason that we have to compile this ourselves is twofold. So if we, I'm gonna pull up my notes. We need two things. We need the ability to capture audio, and we need the ability to enable hardware acceleration. So I'm not going to go through this entire web page, but Ffmpeg has an article on hardware acceleration, and I have an Nvidia card. You might have AMD, and if you do, your steps are going to be different, and I don't know what those steps are going to be. But for Nvidia, or I should say, if you have AMD, take a look at this page and see what you need to do when you're compiling Ffmpeg to be able to install the AMD hardware acceleration. I'm going to show you how to install the Nvidia hardware acceleration, and that uses something called NVENC. I'm guessing that's Nvidia encoder. And you'll see that H.264 is something that's important to NVENC. And it says here that when you compile Ffmpeg, you have to turn that off, which means that when we compile Ffmpeg, we're not going to turn it off, so we're going to get it. We're going to get the hardware acceleration. The second thing is to enable easier audio recording with Pulse. So, and I'll put these links in the description. So in order to get Pulse, you have to set a flag to enable Pulse. I don't know why this isn't by default. Maybe on systems that don't have Pulse, it's in some way destructive. But if you're running Ubuntu, then you have Pulse. So, or at least you do by default. So that means that we need to add an additional flag here. Enable libpulse. So we got to add that. And as far as our compilation goes, that should be it. And that's it. The only modification is enable libpulse. So I'll put that in here. Hopefully this works. It should. Oh, I'm not in the correct directory because I opened a new terminal. So we're going to cd into, for you, it's going to be ffmpeg sources if you didn't stay in the same folder from before. So we'll cd into that directory. Make sure we have a configure file. We do, and it's executable, indicated by the X letter here. So that should be it. We should be good to go. All right, so I guess if it's holding, that means it's doing something. So the configuration doesn't take too long. We'll see what happens here. I thought it would give me some messages. Cool. I don't see anything that says error here. Cool. Just a bunch of information that I don't really care about right now. Okay, so now the Ffmpeg source code that we have is configured. I don't know if it made a new file or something. Whatever it did, we're good to start compiling now. So we're just going to take the very next command that the Ffmpeg documentation gave us, which is make. This is the actual compilation step. I'll keep talking while it's going. This is going to take a while. This is going to take a few minutes, like maybe 5, maybe 10, something like that. It depends on your machine. And I didn't want a new one. While it's running, we can take a look at the CPU utilization. You can see it's relative. I mean, it's not too high, but it's using all 8 of the cores that I have, and it's in the 20s for almost all of them, at least. So it's working hard. I think so. Sometimes you get warnings. I don't know enough about compiling. I guess this is C or C++ because we got header files. I don't know enough about compiling to tell you whether or not these warnings are all that bad or whether warnings in general are bad. When you compile code, I know it's a pretty common thing. But if you get an error, which I have before, then the compilation will stop. And I think when I did the original compilation here, if I remember correctly, I got some errors. And if you do end up getting errors, I think I had errors on, I want to say it might have been YASM. I don't remember what they were. Of course, I wasn't recording at that time. But if you do get errors, read the error message, step 1. Step 2 is figure out which one of these is causing you an error, if any. And then if you're getting that, you can do the manual compiling installation steps for that particular library. I want to say YASM was one, and maybe X264 was another one. I don't remember. If you have trouble, put something in the comments. I hope to be doing videos like this, the Linux installation videos. I hope to be doing them in virgin environments here pretty soon. I'm going to be learning about Docker at work or for work. So that should give me just a virgin, stock, bare bones Ubuntu environment. In which case I should be able to detect any errors that you might run into, because who knows what I've installed on this machine during the time since I installed Linux and since I'm doing any number of these videos. So I might have something you don't, but if I do it in a container, if I do it in a Docker container, then I should be able to encounter those errors. Anyway, we're gonna let this compile. We're gonna let this compile finish. So if you want to skip ahead, now would be the time. If you're still here, and if you're interested, one of the reasons that, or I'm not going to skip or speed up this compilation step because I haven't really gotten into video editing on Linux. I tried some things, like in my League of Legends video, I was able to cut out some video so that it didn't take the full 2 or 2.5 hours that it took for League of Legends to update or to download the whatever it needed. I was able to do a simple cut, but I don't know. I wasn't really happy with the editor that I was using, and I mean, for stuff like this, I do it all in one shot. If I don't do it in one shot, then I feel like that would be cutting, splicing would be jarring, because something would change and you might not necessarily know what it was, especially since I talk over these as I record them. So that's it. Eventually, well, that's it for that side note. Eventually I'll get into some video editing, but for right now I'm not there yet. I want to focus on actually getting stuff working in Linux, and with this video that I'm recording right now, I want to get a better method of doing screen captures than OBS. So once I have those, maybe I'll look into some editors, but I know that video editing on Windows and Mac is a lot more supported. So if you have some suggestions for video editing on Linux, I'd love to hear them. So stick that in the comment. Okay, it's done. I wasn't timing it, but at least 5 minutes, maybe more. Alright, so that was the make command. So now the source code is compiled. I feel like a nerd saying that. So now we're going to move on to the next command, which is make install. To be honest, I don't really know what that does, but whatever. We have to do it to get Ffmpeg to work. So, and also, I don't know what #-r does. I don't know what the hell that means, but I could look it up, but I don't really care. Although, I have to make a disclaimer. I don't care, but in this particular instance, because it's coming from a trusted source, which is Ffmpeg, but in general, if you don't know what a command does, don't just copy and paste it into your terminal. Have you guys ever seen this one? I gotta be careful not to hit enter. Sudo rm/rf/. Looks pretty innocent just sitting there by itself. Doesn't look like there's a whole lot going on, but you'll wipe your entire file system. Alright, so that is all of those are all the steps needed, or that Ffmpeg says we need to do to get Ffmpeg compiled. Where were we? Compilation is now completed, and these other things should now be ready to use. So let's see if that's true. So we'll run which Ffmpeg, actually let me clear this. We'll run which Ffmpeg to see where Linux thinks Ffmpeg is located. And hot damn, there it is. So our path is telling Linux that the Ffmpeg executable that should be run is the one that we created in our user bin folder. FYI, the /home/user. My actual Linux username is user. This will probably say Jeff or Steve or something. That's synonymous with that. The tilde is equal to /home/user. So, FYI. And that's what this indicates. So, alright, so we compiled it. The binary is there. It's ready to be used. So, let's confirm that we do in fact have libpulse. And there it is. So, when we run Ffmpeg from the terminal, we're going to have access to libpulse, which is something that we need. So the next thing that we need to confirm is that, get this over here, is that nvenc is accessible to us. So the way you can do that is to run this command. So this is going to make Ffmpeg list all the encoders that it has, and it's going to send any errors it encounters to dev null. Which means it won't display them. And it's going to pipe the output to grep, and we're going to look for nvenc. And the fact that there are any entries indicates that this worked. The one that we care about, I think these are all aliases, or at least the first three. They're all aliases. I'm not sure what HEVC is, but this is the one we're going to use, this very top one, once we finish what we're doing here. So that's getting Ffmpeg up and running. The next thing that we're going to do is make sure that our audio is ready to be captured. So, assuming you're on Ubuntu, assuming you're on Linux Mint, you are going to have access to a program called PA Control. I believe that stands for Pulse Audio Control. And here is the command that we're going to run to get some of the information that we need. So this is going to tell Pulse Controller to list its sources and look for the names of those sources, because the name is what we care about. Before I run this, though, I'll show you what this outputs first. So that's a lot of stuff. I don't really feel like sifting through all that. If you need additional information at some point, you can run it without grepping, but I'm going to grep for the name. And let's clear it again. Alright, So these are all of the individual pieces of hardware that Pulse is aware of. If you don't see it listed here, like if you have a microphone plugged in and you don't see it listed here, then I'm not sure what to tell you. That might have to do with a problem with the hardware, or maybe you don't have the drivers installed. Who knows? Honestly, the best way to see if it would work for recording is to do a test with OBS. If you do a test with Open Broadcaster before you start doing this, then you can confirm that your hardware is actually in working order, and the associated software. Anyway, what I'm using right now is a headset, so I got speakers and a microphone, and they're the only USB audio. It's the only USB audio hardware that I have installed, so I know it's these two things. Analog stereo is going to the actual headphones, and then the microphone on the headset is analog mono. And I just happen to know that. A little bit more descriptive is the first part, ALSA output. So the reason that ALSA is here, ALSA, is because I can't pretend that I know everything about this, but it seems like Pulse is a software layer that is the easiest to interface with or to interact with, and then Pulse uses ALSA to interface at a lower level with the hardware. I don't know if ALSA is in control of the drivers, so that might be the Linux kernel, but in terms of complexity, Pulse is the simplest, then ALSA, and then the actual kernel, your drivers. So that's why ALSA is there. And there are ways to interface with ALSA using Ffmpeg, but I did not have much luck with it. I was able to get it to work, but it was being so the audio was being recorded, but then that audio wasn't going to my headset. I couldn't get it to be in two places at once. The only way I could get the audio to be in two places at once was with Pulse. So that way I can hear it while I'm doing stuff, and it's being recorded. So we've confirmed that we have the hardware acceleration encoders, and then since Ffmpeg listed the libpulse as an enabled flag, we should have access to Pulse when we run an Ffmpeg command. So anyway, output and input are what we're looking for. So when I'm doing a recording, I want to record the stuff that the computer is spitting out to my headphones. So I'm going to copy this, and we'll go back to my notes. Make a little comment here. We'll say these are my speakers. They're not, but I'll know what I mean. It's just the output, and then instead of input, I'll say my microphone. And the name of that is this. So make a note of these. You're going to need these. Go. All right. So I'm reading the notes that I took for this video. All right, now we're actually ready to run an Ffmpeg command. So the way that I test this is I'm just going to play some audio file, and or anything that contains audio, and record it. So let's see here. Let's find an audio file I can play. All right. So there were a few League of Legends songs that I thought were pretty sweet. So we'll do a test with one of those. All right. So first we'll get the command set up. Before I type this in the terminal, I will go back to my notes here and type it out. So we're going to Ffmpeg pulse. So I don't remember what the F is an acronym for, but that's how you tell Ffmpeg that you want to use pulse. you could use -F also there if you know what you're doing, but like I said, I wasn't able to get that to work in the way that I wanted to. Next, we have to set our input. So that's where the name comes in. So let's take we're going to take the output as the input. So this is the pulse monitor of that particular piece of hardware. And we're going to save this. Let's make a directory in my home folder. So let's see. We'll say ffmpeg tests. And let's go there. Because we're done with the source code. We don't need to be in this folder anymore. All right, nothing in there. And we'll say so, okay, let's break this up. And we're not doing any encoding, so we'll just save it as a wave for right now. We'll get into something a little more advanced later, I think. We don't really need to do too much with the advanced testing. So anyway, so we're going to run ffmpeg. We're going to tell it to use pulse in some way. We're going to say that our input is just the speakers, whatever's coming out of the speakers of the computer, and we're going to put it in this test1.wav file. And since we're already in that directory, we don't need this. You're welcome to include that if you want. So let's take this command and run it. And while that's running, now let's open this up. I don't know where that picture came from. It's not me. All right, that should be good enough. So you can see that when we run this command, ffmpeg keeps the terminal open and puts a bunch of stuff out to it. I get these. I'm not entirely sure what they mean. It doesn't look good, but I haven't had any issues with the outputs. So we should have a file in here now, and we do. Test1.wav. So I'm going to open it up in VLC and make sure that it contains what I think it contains. Okay, that's awesome. Yep. Okay, so there is a successful audio test using ffmpeg and pulse. If we wanted to get my voice, which you're probably sick of hearing by now, we could use the microphone. So let's try that. Well, I'll keep that there in case we need to come back to it. Let's take the mic. And let's run that. Now, we don't, oh, it says it already exists. Okay, let's not do that. Let's make it test2. Or we could say test microphone, if we wanted to be a little more descriptive. So let's put that in there. All right, anything I'm saying now should be recorded. And let's do test microphone. Cool. All right, and that worked. So both pieces of hardware, both the microphone that I'm using and what's being output to my speakers, they're both working. If you wanted to take the debugging here a step further, maybe something doesn't work for you. There is another debugging step that we can do. There is a particular, there's some kind of pulse tool, PAVU control. I'm not sure what that stands for, pulse audio something. If we install that, obviously I've already installed it, then that gives us access to this program here, which for some reason this isn't installed by default. Oops, I really think that this should be the default since Pulse is installed by default on Ubuntu, but whatever. What do I know? So here is the Pulse monitor telling me that Open Broadcaster is currently recording this particular audio stream, right? And obviously it is. And that's Pulse Audio is probably what Open Broadcaster is using to get this little preview here for the audio, but I'm not sure. Anyway, we can see. Damn it! I keep scrolling on these. We should be able to see. Yeah, if we go to the Input Devices tab, we can see that this is my microphone. Something else that this particular utility would help you with is if you can't determine your hardware with that pulse source command. So if I run that again, let's clear it and run it again. So when I run this, if you don't know what any of these are, maybe this could help you figure it out. Like this says mono, and here's one that says mono. It's the only one. Just another debugging tool. But for what we're doing, we don't really need it. I like it though, so I recommend installing it. All right, where were we? So, all right, so we got audio working. And now actually we're ready to do this. There isn't anything else that we really need to do. The video test is going to be the Ffmpeg command itself. So here is the one so I'm going to paste in the Ffmpeg command that I created for myself for this video. So let's break this down. So we're going to run Ffmpeg, and we're going to set the frame rate to 60. So this is going to give you 60 FPS. The next thing we're going to do is the video size. So 60 FPS is good, but if we're only at 720, then it's not as good as it could be. So we want to set the video size to 1920 by 1080. Now, obviously, this is going to be dependent upon your particular setup. If you hear the term 1080p, that's referring to this resolution. This is just width, and then X, and then height in pixels. So for some reason they use the smaller of the two numbers to indicate. I'm surprised that marketing let them do that. If you're not running your monitor at 1920 by 1080, then these numbers are going to be different. The way that we can confirm that is by running the display program, and that will tell you what your resolution is. So mine is 1920 by 1080. Yours probably will be, but you should confirm that. And I am running two monitors. In case you haven't noticed from my videos, I drag stuff off screen a lot. So that's important to know for the next portion of this command, or this option. -F X11 grab. So if you don't know what this means, X, literally just the letter X, is the piece of technology that I think pretty much every Linux distribution uses to display video. It does more than displaying video, but that's what we need it for in this case. It's version 11. I mean, you won't need to change this. I'm just explaining what it means. X is your video server. 11 is the version number, I believe. And then grab, you want to grab what your video server is outputting. X is kind of like the pulse, but for video. That's a gross oversimplification. -I is going to be input, and this is just the syntax. I don't necessarily know what all these numbers mean. This has something to do with the hardware. :0.0. I don't know what :0 means. I just took these from examples that I found online that worked. And 1920, that is an offset. So plus 1920 oh, now I know what the :0 means. Plus 1920 is going to offset the video that you record by 1920 pixels. And the reason I have that set up is so that I can record the second monitor. To give you kind of a visual demonstration, I won't do it in text. Here are the monitors that Linux is aware of. So the first one here is 1920 by 1080. The second one is 1920 by 1080. So the X server is outputting to both of these monitors. So when you record with Ffmpeg, if you don't include something like this, then both monitors are going to be recorded simultaneously. So you're going to get a really, really widescreen video. It's going to take up twice the width of one of your monitors. So when I'm recording, and presumably when you're recording, you don't want to do that. Maybe you do, and if you do, you can just remove this, and that would allow you to do that. But I don't want to do that. I only want to record the second monitor. So in order to do that, I have to tell Ffmpeg to offset the area of video that it's recording by some number. And in this case, that is by the width of the monitor. So if we were to count each and every pixel that goes along the x-axis for this first monitor, we'd arrive at 1,920 pixels. So we want Ffmpeg to only record from 1920 until the end, not from 0 until the end, but from 1920 until the end. And we have a (0) here to indicate that we do not want to offset the height. To give you a demonstration of what that would look like, let's say I had my monitors stacked on top of one another. I'm not going to do that. I don't think many people do. But if you had 4 monitors, they might be like that. If that were the case, I would just swap the 2 numbers. But the height isn't 1920, that's the width. So we would have to set it to the height. So we want to start at 0 on the x-axis and 1080 on the y-axis. But we're not going to do that. I have my monitors side by side, so I want 1920 and 0. So that's what that one does. ALSA hardware 2. Well, clearly that's not correct. So for this, we're going to take... I'm not going to record my voice on this one. I'm just going to record the speaker output. And we don't need that. So we're going to have to say -f pulse. And to make it consistent, there. So this is going to say record audio from pulse and record the audio from this device, which is my speakers. Next is, okay. So here we have the video codec. That's going to tell Ffmpeg that when it's recording video from X11 or from X to use the hardware accelerated H.264 encoder. That's how we're going to get the best performance, the highest resolution, the highest frame rate, etc., is if the hardware is giving us the frames to capture. Next is -BV, so that's the bit rate for the video. Honestly, I don't really have a good suggestion for this because I haven't experimented, or maybe I haven't read enough about video, about H.264 encoding. But I found that 25,000K it kept my videos at a resolution that I liked. I didn't see any pixelation, and it didn't bring my machine down. I was still able to record it. You can change this to whatever you want. If you see your machine getting sluggish or something, maybe change it to 10. I only did test recording so far with Doom, so maybe that's not too demanding on the processor or the video card. So that's for the video. Next, we want to set the audio. Now, I'm doing this part I don't have any notes on, but it should be pretty easy to write. So, oops, not AVCI. I want the audio that gets recorded to be in MP3 format. I could do WAV, but WAVs are huge. If you want it to be lossless, you could do FLAC. Maybe I'll do that in a later video, but I haven't experimented with it. And finally, the bit rate for the audio, I like 192K. All right, and then finally is the actual file that you want it to output to. So I'm going to get rid of that and just state the name of the file. So let's see if this works and what it gives us. Cool. So it's running. I'll go ahead and hit Q to stop the process. And okay, let's see what we got. Cool. So you notice that my voice wasn't in there, and that's because we set pulse to only record the output. So let's try it again. Let's rmrf. All right, I got rid of all the tests. Let's play some audio and record video to see if that actually works. All right. Hot damn. That's pretty sweet. All right. So that's how you do it. There are still two. So if you're watching this video and you've had enough, now you know how to do it. But I'm gonna continue because I want to do a demo with Doom, number one, and number two. It would be nice to be able to get the microphone to be recorded in here as well. So there's got to be some way that we can tell. And at this point, I don't have any more notes. We're gonna have to figure this out I'm gonna have to figure this out as I go. So there's got to be a way to tell Pulse that we have a second input. So let's go back here. Let's see what we can find. Capturing with ALSA. So this is actually where I started out when I was trying to figure out how to record audio, but like I said, I couldn't get ALSA to work. And I don't know that they don't even have a pulse. They don't even have a pulse section here, which sucks. It's worth noting that this is actually, I'm going to put this in my notes. This is a good place to do a little bit of debugging research as well. I'll put this link in the comments or in the description. So let's see if we can get two different inputs. -I. Here's a -I, but they're only showing one. Two sources simultaneously in Ffmpeg. This is this guy's lame. I want it to be in the same file. So let's see what this guy did. A codec, V codec, -F ALSA. Alright, I'm just going to experiment. And if I can't get this in the first one or two shots, then I'm not going to waste your time with it. I'll post a second video. We're just going to experiment and see if we can set two sources. Whoa. It says there's no such thing. What if we take this out? Yeah, we'll overwrite it. And now I'm going to play this MP3, but it should only give me, so I can hear that, it should only give me my voice and not this playing file. Yeah, it's not playing. All right. So I'll do a little bit of, I'll have to do some more research with this to get the microphone and the speakers to be recorded at the same time. For now, just for the purposes of documenting the work, or, the research that I've done so far, this is good enough. So when I figure that out, I'll paste my notes here in the comments so that you can just copy and paste the command if you'd like to. And when I figure out how to get both the speakers and the microphone to go to the same Ffmpeg output, I'll post that as well. But the next step is, well, does it really work? And even if it does, can I really show you from a playing video with in Open Broadcaster? So let's see, we're gonna set, we got this here. Yeah, so that's gonna do the output. So I'll put that back in the terminal. And it should ask me if I want to overwrite. Oh, it's recording now, actually. Shit. Let's not do that. Alright, so we'll keep that handy. The next thing that I'm going to have to do is I want to test this with Doom. So we're going to test it with Doom. Scripts. And I've been doing some demos with PS Doom, so let's do that one. Go ahead and start the recording. As soon as it projects. Yes, I want to overwrite it. Now let's go to Doom. And it's kind of a bitch with two monitors. Alright, here we go. So in Open Broadcaster, this should look like ass. But with Ffmpeg, it should look good. Oh, shit. Bitch. Alright. That's enough. And we'll kill the recording. Let's see what we got here. Alright, it's pretty big. Let's see how big it is. 187 megabytes. So I wanted to show you that because doing 1080p recordings at 60 FPS is not cheap when it comes to storage, when it comes to disk space. That was, what, maybe a minute? Maybe not even that long. And it's almost 200 megabytes. So if you wanted to do something about that, you could tone down the bit rate on the video. And I plan on tweaking that myself, but for the purposes of having a proof of concept that the video quality was up to my standards, this one worked. So maybe I'll tone that down to 12.5. We'll see. So let's see how it turned out. Looks good to me. It's loud. All right. Alright. That's enough of that. So, I'm not sure, like I said, I'm not sure what it's going to look like in Open Broadcaster, but me watching it just now, that looked pretty good. And that's with me recording with Open Broadcaster at the same time. So, yeah, so that is it. That is the best way I know of to record 1080 resolution, 60 FPS screen captures in Linux. Hope this helps you guys, and I'm sure there's lots of room for improvement here. Certain things that could be optimized in the command. Let me know what you think.